So hello guys, welcome back to another video. In this video, we are going to submit our first technical competency project. Our technical competency project's title is Agrocycle. Agrocycle, where we are going to predict the crop yields. The guide for our project is Malesh VS, our technical competency teacher in machine learning club from GM University Davangere. Our technical competency coordinators are Firoz Khan sir, Raviteja Balakai sir, JM University, Davangere. Now I am going to introduce my team members. The first one is Abhishek BS, Ashish Raut, Jaidev myself, and Nitin Yas. So these are the contents we are going to do in this video today. So now let's move on to the introduction part. Introduction part. We all know that agriculture is essential for global food security. One of the major challenge in agriculture is accurately predicting the crop yield. Traditional methods such as manual estimation are affected by weather fluctuations and soil variability. So we can solve this problem using machine learning. When we introduce machine learning through this, using the historical and real-time data, we can predict the accurate estimations. We can generate accurate crop yield predictions, and we can help farmers optimizing resources and increase productivity. So problem statement. Our problem statements are divided into two types. One is current issue and the other is our goal. Okay. Current issues, problems like guess like farmers often guess the yield based on nutritions and institutions, not data. Okay, institutions is like uh, last time ಇಷ್ಟು ಬಂದಿತ್ತು ಈ ಸಲ ಇಷ್ಟು ಬರುತ್ತೆ like that. Okay, so then the other issue is current climate conditions which are unpredictable. Current climate conditions which are unpredictable. It may be sunny in the afternoon. It will suddenly start raining in the evening, or else 1 week full it will be raining. They will think it will be raining. The rain will continue for another week, and they will plant. But due to some seasonal conditions, it will not rain for the next week. It will just become a sunny day. So our goal, our goal is to build an ML based system which will predict crop yield using weather features, soil features, and crop data. So data sources and features. Data types we are going to use here is weathers. We are going to collect the temperature, rainfall, humidity. In soil, we are going to collect the pH level of the soil, nitrogen level of the soil, potassium level of the soil, and the phosphorus level of the soil. In crops, we are going to like collect the past yield, like what was the past yield they harvested, what was the amount of the past yield they harvested, and the stage of growth, at what stage their current crop is growing. And the sources we used here is Kaggle agricultural datasets, government databases, simulated sensors data that is optional. A Kaggle agriculture database, it is an free open source database for all who can work on these types of project. And government databases where they will state some like standard units of measuring units, standard units, what and all they can use, like fertilizers and all, that will be done. Then dataset pre-processing. Dataset pre-processing, before training the machine learning model, the dataset must be clean and prepared. There are some key pre-processing steps we need to follow. One is removing the null values and outliers. This will include missing data and avoiding the training issues. We should remove these missing data to avoid the training issues. Then the outliers, like which unusual values are also called as outliers. Then normalized numerical data, features like temperature, rainfall are scaled in similar range to ensure fair modeling training. Like temperature and rainfall, we must set and standard measuring unit so that it can be scaled down to that unit and then it can be uploaded. Then encode. The third one is encoded categorical values. Encoded categorical values is converting from one numerics to the standard numerics. We will here use temperatures and other numerical values for rainfall and all. So we will convert that, so we will convert those measures into standard measures which we have given for the upload. Next, the tools used here are Python, Pandas for data handling, and skitlearn for pre-processing and modeling. The next part of this presentation will be explained by teammate Nitin.
Thank you, Jagger. I'm myself, Vignesh. I'm going to explain about the model implementation. In this way, which is like languages and libraries. In this way, used Python has our primary programming languages and the implementation implemented the machine learning model using essential libraries like NumPy, Pandas, and scikit-learn. In this way, we explore models like linear regression and neural networks. Linear regression for its simplicity and interpretability. For and I'm going to explain about the neural networks. Neural networks is applicable for more complex pattern recognition. And next, I'm going to explain about an process model. We followed a standard ML pipeline where we performed an 80 is to 60, which is known as like test time comma test. Means in this we use it 80% of testing and 20%, 80% of training and 20% of testing to evaluate the model efficiency. And in this we use cross validation to ensure consistency in programming. And we applied hyper hyper parameter tuning using tools like grid search to optimize model performance. And I'm going to explain about the code part, code implementation. In this code implementation, we started by importing essential Python libraries like pandas for data handling, scikit-learn's model for splitting data, building the model, and evaluating its performance. Let us go for the main part. In this, our entire implementation is inside a main function with a try or expert except block to gracefully handle errors like missing files or incorrect formats. Let us go for the data loading. In this, we loaded the data named crop underscore elk underscore dataset dot CSV using pandas. The dataset should be contains features like temperature, rainfall, soil, pH, etc., along with the target variable eld. Next, I'm going to explain about the uh, column check. In this, we ensure that the target column L is present. If it's missing, the script shows an error. Next, I'm going to explain about splitting features and target. We separate the data set into X, like dependent features like temperature, pH, etc., and Y as dependent target variable, the crop L. Next, I'm going to explain about the splitting training and test data. In this, we splitted the dataset into training and test sets using, and before slide, I have explained like 80 is to 20 ratio. The random state ensures reproducibility. Next, I'm going to explain about the model training. Next, we create a instant of the linear regression model and train it using the training data and prediction and evaluation. After training, we use the model to predict L on the test data. Then we evaluate the model using like R square, indicates how well the model explains the variance, and RMSE, root means squared error, means predict error. Next, I am going to print uh, results. And then finally, we print the performance matrix to the console, which helps us interpret the accuracy for our model. Next is like error handling. We also include like error handling in the cases the file is missing or another unexpected error occurs. Finally, in this screenshot to show this, the code is a live in Jupyter notebook or in VS Code I'm running. To run code, it shows that the actual R means and output. Briefly, like we have to insert a CSV file to structure the possible. In this, we are adding like variables like columns like temperatures, rainfall, CH, pH, NPK, so on. Next, I'm going to explain. um, uh, Datasets. In datasets, we use it like temperature. I'm told before dataset uses temperature. rainfall, humidity, soil, pH, NKP, past and before. Past means it like previous data sets and current end. This is the front end part. Front end, in this front end, we implemented like the front end interface has been designed to make the model like user friendly for the farmers or the agriculture officer, which they can go through like easy to understand and uh, understandable. Throughout the minimum is a prototype. Front end will be explained further. It is like we have created a sample web interface to input soil and weather data and predict button to show the estimate and we show like graph and how much from the rest resources will show like how many crops can be produced. Further plans included uh, interface mobile friendly app to perform accessibility for the farmers. And next slide will be explained by my friend Ashish. Thank you.
Thank you, Nitin. Today I'm going to explain about the model training, which involves the following steps. That is, train models on clean data sets, which means the data was pre-processed to remove noise, missing values, or irrelevant features before training. Next one is validated using test data, which means the model performance was tested on unseen data to ensure generalization. The techniques involved are R square score for accuracy, which which statistically measures indicating how well the model's predictions approximate the real value. Then RMSE for prediction error. RMSE here stands for root mean square error, which measures the average magnitude of prediction error. Then grid search for tuning. It is a method of hyperparameter tuning to find the best combination of uh, model setting. Now we come to model performance. Here, for example, first you have taken the linear regression, which has given the R square value as 0.78. At a 78% of the variation in the target variable can be explained by the model. And RMSC is 5.4. On average, predictions are of 5.4 units. Then best performing model here is linear regression for simplicity and consistency with clean data. We come to result interpretation. Here the key features here are rainfall and pH. Then the insights are soil properties and timely rainfall have major yield impact. Then the data-driven approach can guide farmer decisions, which means it can help farmers make better decisions, likely by predicting yield or optimizing planting time based on weather and soil conditions. Thank you. And the further slides will be explained by my friend Abhishek.
Now I am going to explain the means I will tell the challenges and limitations in our project. The challenge is incomplete data, which impact is affected model accuracy, which means the model accuracy will be affected. The solution for this is we should use the imputation and data cleaning. We should clean the data and use the imputation. Next challenge is limited real time inputs. The impact is less practical. The solution for this is future integration with Internet of Things. Next challenge is overfitting in complex models. Lower the impact is lower generalization. Solution for this is applied cross validation. The last challenge is tech adoption by farmers, which the impact is low usability. The solution for this is planned for mobile friendly UI. And the next is team learnings and reflection. What worked well? Linear regressions produce consistent and reliable results. Smooth coordination and effective task distribution among team members. Challenges encountered are limited time for real world deployment, encountered issues with missing or incomplete data. Key learnings: data pre-processing is critical to model performance, and choice of model architecture significantly impacts outcomes. Next is the future scope. In future scope, that is the further steps are integrate real-time sensor data through Internet of Things, incorporate satellite-based crop monitoring, experiment with self-learning machine learning models, that is auto machine learning, develop a mobile application for farmers. The vision is to build a smart, accessible, and real-time agricultural platform that empowers farmers with the predictive insights and data-driven tools for better decision making. The last but not the least, the conclusion is machine learning has the power to revolutionize agriculture by delivering the accurate, timely, and scalable crop yield predictions through the analysis of both historical and real-time data. Machine learning models can help farmers make informed decisions, thereby optimizing resource use and enhancing food security. Our project demonstrates the potential and of data-driven agriculture as a cornerstone for a more sustainable and resilient future. By saying this, I would like to conclude our project. Thank you.
Okay, thank you, Abhishek. Thank you for concluding in such a nice manner. So now let's we'll check out our coded part, that is our website. This is our website named as Agrocycle. We will predict the crop yield predictions using machine learning. So we have listed out our features, and uh, when we click on get started, now we have to give the input data as said before. Weather in 20 weather in degrees Celsius. Let's assume it is something around 38 degrees Celsius. Rainfall is about 100 millimeters. Humidity is 50%. Then wind speed is around 25 kilometers per hour. Yeah, 25 kilometers per hour. Then we'll go for soil data, where below 7 pH value is acidic, and above 7 pH value is basic. So we'll just give it 7 neutral. Oxygen, like nitrogen level in our soil will be 100. Phosphorus level will be around 95, and potassium level will be around 85. This is just these are not some accurate values. These are just values we are giving for reference. Okay. Now we will select the crop type. We'll select the crop type. We'll select it rice crop type. The crop type is rice, that is paddy. So we have to select the growth stage. Growth stage is like seedling will be the growth stage. From the first we will guess it. Then previous year yield for we'll get we will we'll give the input as something around 2800 kilograms per acres, like that. So what is the planting date of the crop? What is the planting date of the crop? We'll choose 21st May. We'll choose 23rd May for the planting date. So now we'll click on generate predictions. When we click on generate predictions, the predictions are available here. So this impact factors. This will give us what and all input we gave, like rainfall, temperature, soil nutrients, then the soil pH value. And here what we get here, yield predictions. This is predicted value of predicted value of our, like how much yield will be predicted in this harvest. This is not like exactly this, and this will be not be the value. You can observe here prediction range. It will range from 4190 to 4630 kilograms per acres. When we click on view detailed insights, we will get the same value in a graphical manner, where we can understand in more easier ways. So thank you everyone.